All right, example 3. One rectangle has sides twice as long as another rectangle. Our goal here is to look at the ratio between side length, perimeter, and area between these two rectangles. So first we're going to find the ratio of the smaller perimeter to the larger perimeter. All right. First we need to find the perimeter of the smaller figure by adding up all the sides, then we'll do the second to the larger. Finding the smaller figure has side lengths of 1 centimeters and 3 centimeters. 1 plus 3 plus 1 plus 3, because a rectangle has 4 sides, is 8. So the perimeter of the smaller rectangle is 8 centimeters. Looking at the larger rectangle, has side lengths of 2 centimeters and 6 centimeters. 2 plus 6 plus 2 plus 6 is 16. The perimeter of the larger rectangle, thus, is 16 centimeters. So if we look at the ratio between the two rectangles, the ratio of the smaller perimeter to the larger perimeter, notice the word 2 there, meaning we're going to put the smaller one first. 8 centimeters to 16 centimeters. And we can reduce that to 4 to 8, 2 to 4, or 1 to 2. Looking at the ratio of 1 to 2, we know that there are every 1 centimeter of perimeter of the smaller rectangle has 2 centimeters of perimeter in the larger rectangle. The larger rectangle has a perimeter that is twice as large, twice as long. If we laid all the sides out flat, straight, they would be, the larger rectangle would have side lengths twice as long as the smaller rectangle. Now, let's look at area. Find the ratio of the smaller area to the larger area. Now, the first thing we need to do is find the area. We're dealing with rectangles, so area of a rectangle is length times width. Let's find the area of the smaller figure. 1 times 3 is 3. Larger figure, 2 times 6 is 12. Now, let's look at the ratio between the larger area and the smaller area. Specifically the smaller area to the larger area, which means we're going to write it smaller area, colon, larger area. The ratio is 3, this area of the smaller rectangle, to 12, the area of the larger rectangle. The ratio of 3 to 12 simplifies down to 1 to 4. Therefore, we know that the area of the larger rectangle is 4 times as large as the area of the smaller rectangle, even though the sides are twice as long. It's very interesting to think about. The sides are twice as long. The area is 4 times as large. There'll be another assignment and an exit quiz on Google Classroom for lesson 1.5. You can also access these videos outside of this Google form, as well as this slideshow in the notes assignment link thing on Google Classroom.